Welcome to Function Focus Lesson 6. Today will be a lot of practice. Okay, we're going to go over the tricky problems that I gave you in the individual practice from last lesson. Sorry for problem number 1. It was pretty tricky. I didn't intend to make it as tricky as it was, but we will go over it. And you will see what the outcome is for that problem. So today you're going to practice substitution and elimination, both methods. After we go over the tricky problems, we're going to, I'm going to give you more examples using both methods just to clear up anything. And if you have any further questions, of course, you can email me. And then activity 3, I'm going to give you more practice to do individually. It's going to be 6 problems, and some of them you're going to have to use the substitution methods, and some of them you're going to have to use elimination, and some of them you get to choose. Okay, so let's get ready. Okay, looking at the individual practice problems from last class. Just particularly looking at this first one. Okay. 2x minus 5y equals 1. Negative 3x plus y equals negative 7. And I tell you specifically, solve this system using the linear combination or elimination method. Okay. So you have to use that method. Okay. So remember, you have it broken down to 3 steps for a reason. Every problem you do, make sure you're reviewing what each step is. Okay, that way you know what you're doing at each step. So the first step says to multiply one or both of the equations by a number to eliminate a variable. So you have to decide which variable you want to eliminate. Looking at these two, I think it's easier to eliminate y. So why do I think it's easier to eliminate y? Because if I have a negative 5y and I have a 1y, the whole goal is to eliminate by having opposite signs. So this is already negative 5y and this is positive 1. So I can multiply this positive 1 or this whole equation to make this a positive 5. Okay, so I'm going to multiply this by positive 5, the whole equation, not just the y, but the whole equation. The goal is so that I can have negative 5y and positive 5y because it makes 0. Okay, so I'm going to eliminate y by multiplying this whole bottom equation by 5. So the top equation stays the same. 2x minus 5y equals 1. The bottom equation now becomes 5 times negative 3x is negative 15x. 5 times positive 1y is positive 5y. And 5 times negative 7 is negative 35. That was just my step 1. I eliminated y by multiplying this whole bottom equation by a positive 5 to make this negative 5y plus 5y, which cancels out. Now, step 2 says to now add your 2 new equations. Now this equation isn't new, but that still is considered a new equation. This equation is new. Okay. Now when I add them, 2x minus 15x is negative 13x. Negative 5y plus 5y is 0. They cancel out. That was the whole goal. I don't have to write 0y. And then 1 minus 35 equals negative 34. Remember, at any point, you can use your calculators, ladies and gentlemen. Okay. Now I want to solve for that first variable. Okay, so I added my 2 new equations, and now, still in step 2, I'm going to solve for this variable x. So to get x by itself, I'm going to divide by negative 13 on both sides. These negative 13s cancel out, x equals. Now, if you put this in your calculator, you'll realize that this is not a perfect decimal, a perfect number. Negative 34 divided by negative 13. That would be 2.615, da, 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 da. So I'm not going to use this decimal. I'm going to keep it in fraction form. What I do know is that negative 34 divided by negative 13 becomes a positive 34 divided by positive 13, because a negative divided by a negative is a positive. So this is my x coordinate. X equals 34 over 13. This is why I said this is tricky. So if you had an issue with this problem, I totally understand, and I do apologize that I made it so tricky. Okay. So now I have to do step 3 by plugging in this x into either one of the original equations. I'm going to plug it into the second one. So now it's negative 3x plus y equals negative 7. I'm going to plug in this x right here. That becomes negative 3 over 34 divided by 13 plus y equals negative 7. This requires us to know or remember our rules of fractions. Okay. When you're multiplying with fractions, remember this negative 3 basically has a 1 over underneath of it. Every number has a 1 underneath of it. So when I'm multiplying, I multiply across. Negative 3 times 34 is a negative 102. And 1 times 13 is this 13. Plus y equals negative 7. Now, I can't simplify this, so it continues to be negative 102 divided by 13. I want to get y by itself. I'm going to add 102 over 13 on both sides. Plus 102 over 13. Okay. These two cancel out. Now, let's see what we have on this right side. On this left side, I have y equals, and on this right side, I have negative 7 plus 102 over 13. Okay. Now, you have to remember, again, rules of fractions. When you're trying to add or subtract fractions, they have to have the same denominator. Okay, they have to have the same denominator. So negative 7 plus 102 divided by 13, they both have to have the denominator of 13. So I'm going to multiply negative 7 by 13, and I'm going to multiply the invisible 1 by 13. Okay, that's going to make my denominator 13 here. Okay. So negative 7 times 13 is negative 91. So y equals a negative 91. And then 13 over times 1 is 13. Now that my two numbers have common denominators, okay, I can add them. Negative 91 plus 102 becomes positive 11 over 13. So now this is my y coordinate. Again, I'm sorry, so sorry I made this tricky. There won't be tricky problems like this in the future. So my solution is 34 over 13, 11 over 13. That's my solution. For the sake of time and also complexity, I'm not going to check it, but I just wanted to show you guys what this problem looks like. Correctly completed or solved. All right. Now, looking at the rest of the problems, if you would like, please pause the video so that you can see if your answers coincide with my answers. Okay. Again, we're using the elimination method. Okay. Going step by step. Now, you could have eliminated a different variable. If you did eliminate a different variable, that's just fine because there's many options you can choose from. Okay, X or Y. And then that would change the work that's here, but it should not change the answer. So here, this solution would be -5.5, -6. Okay. All right. So your work might look different, but the answer should look the same. Okay. All right. And the next two problems. Okay. Now, I did want to talk about this problem here, which is another tricky one. Okay. So, again, we're solving using the elimination method. So if you look here, we had 6x plus 3y equals 3, and we had 8x plus 4y equals 4. And I chose to eliminate y. I could have chosen to eliminate x. It does not matter. For this problem, we have to multiply both of the equations by two different numbers so that we can eliminate y. So I had to ask myself, 3y and 4y, what can I make the 3 and the 4 so that it's the same number but opposite signs? So I want to make them the same number, but I want to make opposite signs so that they cancel out. So I want to make them both a 12. So I multiplied that 3 by 4 and that 4 by -3. That way it'd be a -12 and a +12. So you multiply the whole equations, and I got 24x plus 12y equals 12, and -24x minus 12y equals -12. That was my first step. When I add the new equations in step 2, I got 24x minus 24x is 0, and then 12y minus 12y is 0, and then 12 minus 12 equals 0. So basically on both sides of the equal sign, I have 0 equals 0. Which is a true statement. Now, if you remember a couple of lessons ago, I mentioned when you're solving systems, if you get an answer like 0 equals 0, or 2 equals 2, or 5 equals 5, or any number equals itself, any true statement, it means that the solution is infinite solutions. It means that the solutions never stop. There are infinitely many solutions. Okay. So I'm sorry if that tripped you up. But if you look a couple lessons back, I think it was lesson 4, I would like to say, I did mention that if you get a true statement, that the solution is infinite solutions. Now, if I would have gotten a statement such as 5 equals 2 or 3 equals 11, that's a false statement. And we then would say that this is no solutions. And that applies for any way that you're solving, if you're solving by substitution or elimination. Okay. Just wanted to clear that up. Now, if you take a look at this last problem, again, you could have solved for a different, eliminated a different variable. I eliminated y, you could have eliminated x, in which case your work would be different here. But your solution should still be the same if you did it correctly. Okay. All right, now, I wanted to do 2 other examples. Okay, 2 other examples just to make sure that we are understanding this and breaking down our steps appropriately. So when you see a system, you can solve a system multiple ways. You can solve it by graphing. You can solve it by substitution, and you can solve it by elimination method. And each time, if you're doing it correctly, no matter what method you use, you should get the same answer. Okay. So I wanted to go over the different options. So let's do substitution for this first one. Okay. If I have -7x plus y equals 10, and 3y minus x equals 10. Okay, remember the first step in substitution is to solve one of the equations for y or x. Now you have to choose which one is easier to solve for y or x. I'm going to choose to solve the first equation for y because y is already by itself and it's already positive. So I'm going to go take -7x plus y equals 10. and I'm going to solve it for y. I'm going to add 7x on both sides. That gives me y equals 7x plus 10. That's it. That's it for step 1. I got y by itself. Now, step 2 says, now plug in this equation you solve for y. Plug that into the other equation. So if I have 3y minus x equals 10, I'm going to take this 7x plus 10 and plug it into y. Because y equals this. Y and this are the same thing. So if I see 7x plus 10, I can substitute that in for y. So now it becomes 3 times 7x plus 10 minus x equals 10. All I did was plug that 7x plus 10 in. Okay. Now, I'm going to do my distribution. 3 times 7x is 21x. 3 times 10 is 30. Minus y equals 10. Now I have to combine my like terms. 21x minus 1x is 20x. Plus 30 equals 10. Get x by itself by subtracting 30 on both sides. 20x equals negative 20. Divide by 20. Okay. X equals negative 1. So now I have to take that. So that was the whole goal of step 2. Step 2 says solve for the first variable by substituting. That's why they call it the substitution method. Now I'm going to take this negative 1 and I'm going to plug it into either x equals negative 1. I'm going to plug it into either of the equations. Doesn't matter which one. Let's say I choose the first one. Negative 7x plus y equals 10. I'm going to plug that in here. So it becomes negative 7 times negative 1 plus y equals 10. Well, negative 7 times negative 1 is positive 7 plus y equals 10. Okay. Get y by itself by subtracting 7 on both sides. Y equals 3. So my solution here is negative 1, 3. Okay, again, for the sake of time, I'm not going to check it. I do apologize if this throws anybody off. But all you would do is, for example, plug negative 1 in for x of this equation, 3 in for y, and make sure it equals 10. Then you would plug it into the second equation for y and for x and make sure it equals 10. If it is a solution, it will work for both of the, it'll give you true statements for both of these equations. Okay. Now for the second one, let's use a different method. Let's use a different method. I want to use the elimination method. We're going to use the elimination method here. And excuse my nails, y'all. We're living in hard times. All right. So with the elimination method, the goal is to eliminate a variable, x or y, by multiplying one or both of the equations by a number that makes the variable coefficient opposite sign but the same number. So for example, here I have 4x minus 5y equals negative 11, and I have x plus 2y equals 7. If you look at these x's, you have to choose which variable will be easiest. And I think the x's will be easier to eliminate because I can keep this 4x the same, and I can make this 1x a negative 4x so that they cancel out. Okay. I could eliminate y, but that's not easier because with this y, I'm going to have to multiply both equations by a number. Okay, so now I'm going to multiply both the bottom by -4. Again, because that's going to make this x a -4x and this a positive 4x. That way they cancel out. So this equation stays the same. The top equation stays the same. I get 4x minus 5y equals -11. And on the bottom, I get -4x minus 8y equals -28. Okay, all I did was multiply that -4 in. So now I'm going to add, step 2 says add the two new equations. So I have 4x minus 4x gives me 0. They cancel out. That was the goal. Now I have -5y minus 8y. Now -5 minus 8 is -13y equals, and then you have -11 plus -28, which is going to be -39. Okay. Now, I'm going to get y by itself by dividing by -13 on both sides. Y equals +3, because a -39 divided by -13 equals 3. So that's my y coordinate. Now I have to plug this in or substitute this in into one of the original equations to solve for x. I'm going to choose the second equation. So x plus 2y equals 7. Plug this y into here where it says 2y. You get x plus 2 times 3 equals 7. Well, 2 times 3 is 6. X plus 6 equals 7. And in order to solve for x, I'm going to subtract 6 on both sides. X equals 7 minus 6, which is 1. So my solution here is the point 1, 3. Okay. That's my solution. And again, if you think that my solution is incorrect, plug it in to both of the equations. Plug the x value in as 1 and plug the y value in as 3, and make sure you get true statements. I hope these two examples have helped you out a little bit. For your individual practice, you have 6 problems. For your individual practice, you have 6 problems. Okay. Now, I want you to make sure you recognize that each problem tells you which method to use. So the first says use substitution to solve this system. The second says use substitution to solve this system. The third says use linear combination or elimination to solve the system. The fourth says the same. Okay. But the last two, however, ask you to use whichever method you prefer. Because remember, either method will solve any system. So you choose the method that you're more comfortable with. Make sure to remember each step. Use your notes from previous classes or previous lessons. Okay. I will be posting these answers tomorrow evening, just so you can look over them before lesson 7, so that you can see if you have any questions, and you can email me if you have any questions, any further questions. Hope everybody's staying safe and happy, and see you next lesson. Bye.